Hi everyone, this is Real World Audio. We are continuing our layout for the Baby Darling amplifier, and as I explained, we have the chassis size of 11 inches by 14 inches. This is the one that I minimally recommend for your Baby Darling amplifier build, and actually you could do all of the Darling builds that I'm proposing on this size if it's really you need to build a small amplifier. But if you want to go the bigger one, I really cannot emphasize it strongly enough. Choose 14 inches by 18 inches. However, let's come back here. What do we have? So the front of your amplifier will be the signal section. We have the inputs, the RCA jacks. You will mount them on your top panel. So this is the top panel, and we are seeing the inside of it. So this is your amplifier. Imagine it upside down, and we are looking at the front, top plate of the front. And your signal, the RCA cables are here, and on the inside you will take the signal into your volume control pot. So it will be mounted like that, so you can adjust your volume on the top of the chassis. So it will be like sticking up when you look at it face up, and then you will have the volume control here and the RCA jacks sitting next to it. So this is where your signal will be going in. And here what your consideration is to keep these three close to each other, because then you can use a shorter piece of wire to run from here to the volume controls leg, and then from to the volume control you need to run both the center conductor and the ground as well. So the grounds of the input signal, they meet at your volume control pot. And then the next thing which needs to be close to your volume control pot are the input tubes. These are the 6J4s, and the signal goes from the center of your, that's called the Viper. So the Viper, you see it, this is a stereo pot. It means one channel and the other channel. You can pick left or right or left, doesn't matter, just choose one for each. And then from the right, let's say you connect it here, and then the Viper will go to the input grid of your input transformer. So there will be a direct connection there through the grid stopper resistor. And then you want to make this wire as short as possible, this wire as short as possible, so that you do not give the signal a chance to pick up noise. Because the longer this wire is, let's say you put your tubes here, then it has to run this way, and it has so much more chance to pick up noise from inside your chassis or from neighboring equipment. But when you make it shorter, then there's much less chance for noise pickup, and also there is much less chance for signal degradation, losing your signal. And then you need to put the output tubes, these are the output tubes, close to your input tubes, so there's not much distance between them, because you don't want to put your output tubes far away, because then the signal will have to travel a long way, and the longer it travels, the same problems it will face. It will pick up noise and it will degrade. And between these two, of course, you will need your coupling capacitor. You can use any kind of coupling capacitors. I have few recommendations, but if you use a high quality one like this, or maybe use a V-cap, or let me just pick you one from my bag of obligatos. This is a smaller obligato. What size is this? This is a 300 nanofarad, so it's a third of a microfarad. It's this size. And this is a 1.5 microfarad 600 volt rated film cap, and this is a V cap which is 0.22 microfarad 600 volt rated, and this obligato is a kilovolt rated. So this is the size, the approximate size. You can choose any capacitor that you like, and but it will be about this size. So you will need something which is about that size. Let's say we use something like this capacitor. So it will have to go between these two tubes, and that's a nice approximate distance. And here I would say that because of this amplifier's particular schematics and build, let us keep the tubes a little bit closer than usual together. Normally, if you use high power tubes, you want to keep the tubes far away from each other, at least like, let's say, like 10 centimeters or 4 inches between them, because the closer they are, they start to magnetically interfere with each other. Also, if they are close to a transformer, the transformer's very strong magnetic field will impact your vacuum tube. Here, because we use such low voltages, I mean low in a vacuum tube world, and it is such low power output, these tubes generate a very small magnetic field around them. It's not as much of a problem as, let's say, in a case of a Heathkit WM6, which puts out loads of power, and those KT88s that it runs generate quite a bit of electrical field. So there you might want to be more cautious about the magnetic fields and respect it a little bit more. So here we can carry on with a little bit more freedom. And also what we have is that we have spatial distancing, because what you can do is not just the physical distance between them, but also we operate in 3 dimensions. So you go with height. So these will be here or output transformers, and these take the signal directly from your power tube. So one of these wires, it will be a red wire, and I think it depends on your transformer. It has red and blue wire, probably the blue, if it's colored blue, then that goes there, or maybe it just has tabs, then the appropriate tab will be connected there. We will figure that out later how it goes. In this case, these are not the actual output transformers, these are just hero placeholders. But what you need is you need to put it as close here as possible, because the wire that's in between them, that's also picking up noise, and you want to pick up as little noise as possible and to keep your plate load as close to the plate as possible. And here, the output transformer will be on the inside of the chassis, and your tube will be sticking out on the outside. So this, we are looking at the top of the amplifier, and then you will have your power tubes sticking up, and these your output transformers will be underneath the chassis down there. So you will have that separation between tube and transformer. So let's go back here. So your tubes will be mounted to the chassis like this, and we will have coupling capacitors coupling each of the input tube to the power tube, and you will also have your volume control and inputs here. And let's see, now let's follow the signal. So the signal follows from input pot, input tube, coupling capacitor, power tube, output transformer, and then the binding post for your loudspeaker, which we will mount right next to it. So it will look like on the chassis, it will be like your power tube is here, it will be close to the power tube on the side, left channel, right channel, they will be like that, and the RCA jacks will be here, volume control here. This is how it will look like, and the power transformer will be sticking up in the back. So let's go back here. So this is how the signal flows, and now we ticked out everything, and the first half of the amplifier is dedicated to the signal section. I have not gone into the grounding yet, and what about the cathodes? So let's just have a word about that as well. Maybe in the next video. Yes, let's make it in the next video. So thank you for tuning in. In the following videos, we will talk about the power supply section, and we will also talk about the grounding and what we do, because we have not yet seen how the cathode bypass capacitors go in and how the ground plane works. Thank you for tuning in. Please like and subscribe. Bye bye.